7.4 and 7.5. Thank you. Solving trig equations. Solving trigonometric equations. 7.4 and 7.5. Okay. Without telling you, or without, I shouldn't say without telling you, but without even talking about the idea, we solved many trig equations. Here is an example that we solved a long time ago. We said, okay, if cosine theta equals 0.3, how do I determine theta? I apply a function. I'm not multiplying it, right? I'm applying a function. Which function?
Inverse.
Yes, because inverse cosine will kill, if you want, will remove cosine, right? But I have to do it to both sides. And then I get theta equals cosine inverse of 0.3. I put in the graphing calculator because I have no idea what this is. So if I want the answer to be in radians, I keep it in radians. If I want the answer to be in degrees, I go back and change it into degrees. And then I apply cosine inverse to 0.3, and I will get whatever degrees. I will get roughly 73 degrees. So theta approximately 73 degrees. We did this in the past. Okay. Now we have different other types. On page 522, I want to show you a few types. And let's start with the simple one. Yes, there is some such thing as simple. 14. Tangent theta equals 1. Now here's a question for you. What is the period of tangent? Pi. Cotangent and tangent have period pi. Everything else has? Excellent. So keep that in mind for a second. Good. So I'm asked to solve. Question was, solve the given equation, which means I have to present all possible solutions, not only between 0 and 2 pi, all possible solutions. Good. So then I go to the unit circle. The next step, I'm asking myself, where is tangent positive? And I will say tangent is positive when both sine and cosine have the same sign. Exactly. So I already know that for now, I will have two different thetas, one that ends in the first quadrant and one that ends in the third quadrant. Which theta ends in the first quadrant? There is only one angle whose tangent is 1, because there is only one angle for which sine and cosine are equal. Exactly. So it's pi over 4 plus, what is the period again? Yes, pi k. What is k? K can be 0, plus or minus 1, plus or minus 2, dot, dot, dot. So here's what it means. Here's what it means. I hope you agree that this is the angle right here in the middle. This is the angle pi over 4. You agree? Good. So if I apply tangent to this angle, I get 1. But if I apply tangent to the angle pi over 4 plus 1 pi, so pi over 4 plus pi, I will get the same answer. So if k is 0, I only get this point. If k is 1, then I get pi over 4 plus pi. Well, right here, tangent of this angle will still be 1. Then if k equals 2, then I have pi over 4 plus a complete rotation, and I'm back here. If k is 3, then I have 1, I have pi over 4, a pi, a second pi, a third pi, and I end here. And tangent of this angle is still 1. And if I go backwards, let's say with k equals -1, then I have pi over 4, but minus pi, I land here. Tangent of that angle is 1. If k equals -2, then I have pi over 4 minus a complete rotation, I land here, still tangent is 1. So the reason what the explanation is all about is the fact that these are infinitely many solutions, not just one. So here, as many times as you want, back and forth. Now, what will this be? 1 pi, 2 pi, 3 pi, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, plus pi k. That is the second option. However, this option is included in this. So if you only present this solution, you have both in mind. And we saw that, how this happens with choosing any k. When I write the final solution, I can write just this, but I have to write k can be any integer. You cannot say 1.3. It's not going to land in these 2 points. It has to be an integer or 0, of course, any integer. You can present both, but condensed, the solution condensed is just this, with your observation that k can be any integer. And this is the solution. Infinitely many solutions, actually, because of k. K is anything, any integer. So therefore this will continue as many times as you want for any k that you want. Is this clear? Every time we solve a trig equation with a function other than sine and cosine, we have to state a restriction. So this is a ratio. This function is, as you know from the big chart, is not always defined. It's sine over cosine. So therefore cosine theta cannot equal 0. But cosine theta for pi over 4 or 5 pi over 4 is never 0. So all solutions are safe. This is always fulfilled for pi over 4 or 5 pi over 4. So for this solution here, this angle, or this angle here, cosine is never 0, so we are safe.
So when we see this laid out, so our first example of theta,
yes,
you said cosine theta equals 0.3.
Yes.
How do we know the difference from seeing that to seeing this to know that there are 2 different answers?
No, it's a very good question. This was just a refresher for you to remember that we had solved this in the past.
Right.
But here I did not say the conditions, so I should have said present all possible solutions. So I would have presented 73 in the first quadrant, okay, right? So this will be 73, but then also 360 minus 73, because cosine is positive on your right, first and fourth. So I would have had to write 2 solutions. I didn't go that far with this. I was just, this first problem was just a refresher that we used this concept before.
Yeah, right. I was just saying, because like,
yeah, in this case, that's a very good question. So here's your 73, right? So on the same vertical, they both have to have the same measure for cosine, which is 0.3. So this is the other angle, which will be 360 minus 73. So you will have a theta 73 degrees plus 360 times k, because the period for cosine is 360. And the other option will be approximately 360 minus 73, what that is. It doesn't, you can calculate that, 360k. And I have to specify that k is any integer, 0 plus or minus 1 plus or minus 2. Very good question, actually. So I have to calculate this. How much is 360 minus 73? So it's 287. So it's 287 plus 360 degrees k. If you write this in degrees, then you have to write 360k. Okay. If you write this in pi, then you have to write pi. Okay. You can have pi and degrees in the same answer. Very good. Very good question. Okay, let's continue. Let's say problem 28. The square root of 2 cosine theta minus 1 equals 0. I'm asked to solve for theta. But I can solve for theta before I solve for, of course. So I have to solve for cosine. I move 1 and divide by the square root of 2. So I have that cosine theta equals 1 over the square root of 2. I have to rationalize because I didn't remember anything that is not rationalized. So cosine theta is definitely what?
Square root 2.
Exactly, and I know exactly which angle that is. But again, I have to identify the quadrants. Where is cosine positive? Yes, in the first and the fourth. Good. So then I will have an angle in the first, which is definitely we have to remember the little 45, very good. Pi over 4. So this is the pi over 4. I draw the vertical line. It crosses the circle in the fourth quadrant somewhere. And then I know that this is the other angle. Yes, 2 pi minus pi over 4. Or you say 2, 4, 6, 7. 7 pi over 4 and pi over 4. Plus what? Cosine, the period is 2 pi.
Oh, 2 pi k.
2 pi k. And that's it, and it's done. But you have to write, this is a must, that k equals 0, plus or minus 1, plus or minus 2, and so on and so forth, because no one else knows what that is. Yes, we do, but okay. Pretty straightforward. If we have a good command of the unit circle, this should not create any difficulties.
So find k will always be the period, or is it? Oh no, never mind. Yeah,
K is an integer.
yeah, but like I was saying, find it. So like the 2 pi or pi, it would just be the period of the.
Yes, of the function you're solving for. In this case, I'm solving a trig equation with cosine. I don't even have to state any restrictions. Cosine exists everywhere.
Right.
But since cosine has the period 2 pi, then I have to use 2 pi k. Yes, perfect.
So OT you have to say restriction for is going to be
Tangent,
cotangent,
cotangent, secant, and cosecant. Never for sine and cosine. Good. Okay, so let's move to slightly more difficult situations. 41. 4 cosine squared theta minus 4 cosine theta plus 1 equals 0. Good. So what do I do now?
Can you pull a 4
Okay,
and a cosine?
there are two key words in all math class. Or,
Another one.
okay, good. So look at this carefully and tell me what to do. No, we will not. It's a quadratic equation in cosine. If it's a quadratic equation in cosine, I cannot pull out anything. That's why we signed an agreement. The first day of classes, and this is one of those 3.
So it equals.
Yes? That's why I said please.
Alright, so we got cosine
The cosine.
squared.
Yes?
Cosine theta.
Cosine theta.
But what about 4?
4 cosine.
No.
Can we divide by 4?
No. It would be a tragedy if I could, because then I would have cosine squared minus cosine plus whatever, and that's not factorable.
Oh, it's 2. Is it 2?
Yes.
2 cosine.
2 cosine theta. No.
No.
Minus
Yes.
1.
Exactly. 2 cosine theta minus 1 raised to the
Same power.
yes. So again, you're resisting those 4 formulas. And I could chase you around the block. Not today. Yeah, there was a sign, a very nice sign in Germany somewhere. I don't remember. I think it was Frankfurt or Offenbach. So it was sign. It said Smoking is forbidden today. So, cosine theta equals?
Oh, maybe just find the square root of this side?
Right, there is only one solution. So 2 cosine theta equals 0, so 1/2. Good. So let's look at the unit circle. Where is cosine positive?
First.
Yes? In the first and the fourth. So now I need an angle whose cosine is 1/2. Nope, pi over 3. Very good. So pi over 3 is 60 degrees. So this is pi over 3. I have to draw a vertical line. The vertical line crosses the circle in the fourth quadrant. And this will be the other angle. So there are 2 thetas in here. Infinitely many thetas, but 2 distinct. What are they? The first theta is pi over 3.
Plus.
Yes?
2 pi k.
Right. You understand what happens, right? If k is 1, if k is 0, I'm here. If k is 1, I'm here plus 2 pi. If k is 2, I'm here plus 2 complete rotations, and I can go on forever. And what is the other one?
Let's see.
Yes, because from 2 pi, you subtract pi over 3, right? So it's 6 minus 1, 5 pi over 3 plus 2 pi k. So from 2 pi, I subtract the reference angle. 2 pi minus pi over 3, 3 times 2 is 6, 6 minus 1 is 5. Okay, please feel free to choose anything you want between 25 and 56, and I would like to show you the other ones. Between 25 and 56. 25 and 56 on page 523. Let's choose 2 more problems, whatever you want, and then I'd like to move on to the last section, which they're slightly different, but not that much. You'll see what the difference is in a minute. Do we need anything else? Remember, factoring and simplifying are crucial. Once you know these factoring and simplifying, your life in math will be always much easier than if you don't.
So we have like sine squared or cosine squared or tangent squared. We just move that out, move the whole.
Let's do it. I don't know, which one are we looking at?
Oh, I was just looking at 46, 47,
46.
49.
Okay, let's look at 46.
Well, that was not the one I was.
Okay,
49.
49. 49 it is. Okay, so we have sine square theta equals 2 sine theta plus 3. Yes, what did you have in mind?
Just move everything over there, make it look quadratic.
Because it's quadratic in sine, and you have to solve for sine. Your responsibility is first to solve for sine, and then once you have sine x equals blah, then you can always determine the angles. Very good. Sine squared theta minus 2 sine theta minus 3 equals 0. Just imagine x squared minus 3x, minus 2x minus 3 equals 0. This is what you should have in mind. But instead of x, it's sine. So how will I factor this? I mean sine theta.
Sine 2 minus 3.
Okay. Very good. Excellent. You can always check. Sine squared plus sine x minus 3 sine x is that, and minus 3. Excellent. So now I have 2 solutions for sine. Sine theta equals 3, and sine theta equals
-1.
excellent. Okay, let's look at the first one. Any suggestions for the first one? Any suggestions for the first one? Yes?
So it's in radians.
This is a number. This is the angle.
Oh, so you have to do sine of negative or the inverse of sine.
But sine can't be greater than 1, so it doesn't exist.
Thank you. He saw fumes coming out of my ears.
You're stuffing it on.
Impossible. There is no angle whose sine is 3. Excellent. We agree, right? What is the maximum possible sine? What is the minimum possible sine? Correct. So then I have only one equation to solve, which is sine theta equals -1. Of course, I have to go back to the unit circle. Where is sine -1? Careful. Sine is measured on the y-axis. Where is -1? Correct. Right here. So theta equals 3 pi over 2 plus what? Depending on the period of this function. 2 pi k. So k equals 0, plus or minus 1, plus or minus 2, and so on and so forth. Very good. Good pick. Anything else from this page before we move on? Look carefully and say this or that, or we move on.
Is there going to be very many with like secant, cosecant?
Anything. Just choose, please. Anything that catches your eye. Yes? Which one?
Maybe 50.
You said 50?
Actually, no.
Perfect.
Yeah,
Perfect pick. Perfect pick. So we have 3 tangent cubed equals tangent theta. Perfect pick. Now, before I even attempt this equation, I know that the trig function we see here is a ratio of 2 other functions, and they will not exist when, yes. So when I finished solving this equation, I will look at all solutions we came up with, and we will verify that for all those solutions, cosine is not 0. If I find solutions for which cosine is 0, I will have to say, no, these cannot be solutions. Just the rest can. Perfect. What will you do with this?
Or you try to get it all on one side?
Absolutely. Factor, simplify, factor, simplify. Next, what do I do?
You have to fill in the tangent square.
Factor out. There are 2 terms, and they have what in common and what degree? Yes, tangent theta. What is left in parentheses?
Tangent squared minus 1.
What about 3?
Yeah, that's it.
3 tangent squared minus 1. So far we have 2 options. This product can be 0 in 2 different situations. What is the first situation in which it can be 0? Don't solve for anything. I just want to give, yes? Tangent theta equals
1/3.
we're not there yet. I'm here. 0. And the other option is tangent square theta equals 1/3. I move 1, divide by 3. These are the 2 options so far. Would you agree? What is the degree of this expression in tangent? So I should get how many solutions?
3.
Correct. Good. So let's analyze tangent theta. 3 solutions meaning in tangent. And then they can branch into more. Right. Okay, so for now we are solving tangent theta equals 0. Go back to the unit circle. When is this ratio sine over cosine 0? Only when sine is 0. Perfect. Tangent is 0 when sine is 0. Perfect. Okay, where is sine 0 on this unit circle?
5 or 2 and 2.
That's 1 and that's -1. Because that's measured on the y-axis. So I'm not talking about 1 and -1. I'm talking when sine is 0. Yes, and where else? Exactly. That's where sine is 0. Therefore, tangent theta equals 0 has 2 options. Theta is 0 plus pi k. Of course, you can disregard the 0. And tangent, the other option is Oh, if you were write 0 to pi is the same thing.
Oh, pi.
So it's pi plus pi k, and I have to explain what k is, and I have to always write it 0 plus or minus 1 plus or minus 2, and so on and so forth. So for any of these solutions, you can disregard the pi k for a second. If I plug in 0 here, is it 0? No, because cosine 0 is 1. If I plug in pi in here, cosine pi is 0 or not? No, it's the other side, which is if cosine 0 is 1, cosine pi is negative 1. Good. So solutions are safe. I checked against the restriction.
Do we only have to write one? Can we only write the top of 0 plus pi k?
Say it again.
Can we only write, like, if we were doing a taking a test, would 0 plus pi k be acceptable as the only answer? For, like, if that was, like, if we were just finding tangent theta equal 0 right there? Because wouldn't...
Yeah, you want to condense these two?
Yeah.
I completely agree.
Yeah.
Because, yes, 0 plus pi k, yes. So you can consider this one in there. I'm fine.
Okay.
Yes. Okay, now from here, what do I have to do to get 2 more solutions for tangent? Exactly. So I have tangent theta. What do I have to write? Because if I forget this, I only get one solution. Plus or minus. The square root of 1 over the square root of 3, and I rationalize. Okay, so now there are 2 different situations for tangent. One situation is positive the square root of 3 over 3. And I have to solve this. And the other one is tangent theta equals negative the square root of 3 over 3. Let's start with the first one. Tangent positive, where? Where sine and cosine have the same signs. Perfect. Now, my professor told me not to memorize this. That's not a problem, because if the top is 1/2 and the bottom the square root of 3 over 2, then when I flip, I get this. If I have the other one, which is the square root of 3 over 2 over 1/2, when I flip, I get the square root of 3. So it's the first angle, the tiny one, which is pi over 6. So this is pi over 6. Here's how I determine the other one. Look. This is pi over 6. And this is pi plus pi over 6. So this is pi plus pi over 6. 7 pi over 6. So this has 2 options. Theta equals and theta equals. And yes, you can condense them into one.
So theta equals pi over 6 plus pi k.
And the other one?
7 pi over 6.
I still have 2 more from here. Because tangent is negative. Where?
Opposite.
Any questions so far? Let's stop for a second, and any questions? Is it clear what we're doing? Yes.
Okay, I got pi over 6.
Oh, remember I said do not memorize tangent. So we have 2 options. For pi over 6, we have 1/2 over the square root of 3 over 2, sine and cosine. And for pi over 3, we have the square root of 3 over 2 over 1/2, the reverse. When I flip this, I get the square root of 3, so it cannot be pi over 3. When I flip this, I get 1/2 times 2 over the square root of 3, and I get 1 over the square root of 3. And I know that this is the square root of 3 over 3. So that's why we have to go with pi over 6.
Could we also use the tangent inverse?
You could, but pi over 6 is not going to give you, it's going to give you a number that you don't know what it is. But if you use a tangent inverse of 30 degrees, you can. But then you're going to get this, and it's an irrational number. It will be difficult for you to convert it back. So remember, we only have 3 angles. 1/2 the square root of 3 over 2 for, let me go this way. 1/2 the square root of 3 over 2, the square root of 3 over 2, 1/2, the square root of 2 over 2, the square root of 2 over 2. There are only 3 angles. And there is a repeat, reverse, for the bigger angle. Okay? So please work on those. So now we are here. That's the last one. Now I have to check, right? So these are my solutions. And I want to go back here and say, okay, is cosine 0 there? So I have a cosine pi over 6. No, cosine pi over 6 is not 0. Cosine of which angle is 0? Pi over 2 and 3 pi over 2, not of pi over 6. Same thing with 7 pi over 6. Is cosine 7 pi over 6 0? No. Only sine pi over 2 and 3 pi over 2, only cosine pi over 2 and cosine 3 pi over 2 is 0. So these are safe. Correct? Okay. And the last one, I have tangent theta equals negative the square root of 3 over 3. So then I go to the second quadrant and the fourth quadrant, where sine and cosine have opposite signs. So then what do? I already know what angle I'm looking at. The reference angle must be pi over 6. So the reference angle is pi over 6. This is the reference angle, and this is the reference angle. So this angle here will be pi over 6 short of pi. So this angle between the initial side and the terminal side, this will be what? Pi minus pi over 6, which is 5 pi over 6. So theta is 5 pi over 6 plus pi k. Good. What will be this angle then? This is the reference angle is still pi over 6. But this time I'm referring it to 2 pi. So what will this angle be? 2 pi, exactly. Minus pi over 6, 11 pi over 6. Thank you. Plus pi k. And of course I have to write, we already wrote what k was, so we can consider that done. Any questions? Okay, so now the last one here is more trig equations, and they're slightly different, and you'll see in a moment why. If they're a little bit more involving. Same idea, everything the same. Okay, so on page 528, I would like to start with problem 20, and then you can choose the next one. And you will see what is different here. So we have 2 times sine 3 theta plus 1 equals 0. How will you address this? What will you do?